Okay, we talked about a one-to-one function and its definition, and I want to present the contrapositive definition. No big deal that if you don't know what that means, but it says if f of a equals f of b, then a equals b. Okay, if when the outputs are the same, the inputs are the same, then that function is one-to-one. So again, on a graph, right, a one-to-one function is much easier to see. But algebraically, like, how do I know? I don't really want to graph all of these. How do I know if it's one-to-one? So the first thing we need to do is determine, is it a function? So an x to the third, right, just understanding a basic about graphing, I know it does something like that. It's going to be a function. But now the determine, oftentimes as well, it'll tell you, here's a function, tell me if it's one-to-one, right? So you don't really need to prove that it is in fact a function, but we could. So if f of a equals f of b. So what is f of a? Well, f of a just means substitute a in for x, right? So a to the third plus 1/2, that's f of a. Make it equal to f of b. Well, then that just means substitute b in for x, right? There's f of b. So if this is true, and I do some work and I end with a equals b, then that means that this function is one-to-one. By the way, if you ever see me write this 1-1, it kind of looks like 1 minus 1 or absolute value of a negative. Like, it's kind of weird. I'll try to do like that so it looks more like 1-to-1, or I'll just write it out. 1, 2, 1. Okay. Anyways, so let's look at the math here. We have this equation. I'm trying to solve for a. So I'd subtract a half. Well, that's weird. These cancel, right? And then I have a to the third equals b to the third. How do you get rid of a third power? You have to do a cube root. But if I cube root a to the third, I get a, and if I cube root b to the third, I get b. So then the question is, well, wouldn't that always happen? Not necessarily. So there's more than one way to think about this, but I'm going to take the same approach for these next two. Okay, and then if we get a yes, we'll find the inverse. So this one, yes, it is one-to-one. Okay, so we will find the inverse. And the inverse, let me throw this in here as well, is usually denoted f to the negative 1x. Okay, that's the symbol for an inverse function. All right, but I want to, before we move forward, like show you what is a function that is not one-to-one look like. So one thing to note, 1 minus x squared, you should have a basic understand this is a parabola. Even if you don't know that it opens down, this x squared implies it's a parabola. Right away I know it's not one-to-one then, right? It does not pass that horizontal line test. But again, I'm not going to graph all these. What if this had more? You know, what if it were divide x to the fourth or something? Like, I have no idea what that graph would look like now. So instead f of a equals f of b, we have g. Doesn't matter, right? G of a, substitute a in for x. G of b, substitute b in for x. Now solve for a or b, it doesn't matter. Subtract 1, those are gone. Divide negative 1, because I have negative a squared equals negative b squared, right? I would divide by negative 1. A squared equals b squared. And then you think, well, once you square root it, a equals b, so this should be one-to-one, but not quite. Remember, when you take a square root, then your result becomes plus or minus, right? Plus or minus square root of b squared, which is b. But anytime you do a square root, you have to remember that you might be talking about the positive, or you might be talking about the negative result. So let me prove this right here, right? Like if you're still kind of, I don't get it. What is 2 squared? Does that equal negative 2 squared? Yes. But if you just square rooted, you're telling me that 2 equals negative 2? No, right? That's why we need, when we do this square root on both sides, you have to have that plus minus. Because that square is going to make my answer positive no matter what. Right? 4 does equal 4. 2 squared does equal negative 2 squared. But that does not mean 2 equals negative 2. So there's an example of when actually you do this algebra and it's not true. Another way to just start this and know that it's not one-to-one, I could say, well, if I do g of 2, I would get the same thing as g of negative 2. And because the y's are the same, right? This says if the y's are the same, I have the same x's. But the y's are the same, I do not get the same x's, right? 1 minus 2 squared is not going to be the same as 1 minus negative 2. I'm sorry. It is going to be the same, but the x's are not the same. So just because they result in the same thing, we would get negative 3 for both. Right? The y's are the same, the x's are not. All right. I wanted to throw in this last one because it's a bit more work, but we can still do this. F of a means 1 minus a over a. Right? Substitute a in for the x. F of b, substitute b in for the x. How do we get a by itself? Well, this one takes a little more work. We could just do cross products because we have a fraction over fraction, fraction over fraction, or multiply by the LCD. You know, whatever you find easiest. I'm going to go ahead and do it this way. This becomes b multiplied by 1 minus a equals a multiplied by 1 minus b. And now if we distribute, b minus ab equals a minus ab. And now if I solve for a, right, I'm adding, I guess I would add this ab to both sides. And then I get a equals b. Right, these cancel, those cancel, they're the same thing. A equals b, and therefore this is 1-to-1. This middle one is not 1-to-1. And if it's not 1-to-1, you cannot find the inverse, an inverse function. You could find an inverse relation. Remember, that just means switch x and y. So all we'd have to do is switch this y with this x here. But I'm asking for an inverse function. Okay. So to find the inverse function, I know it's 1-to-1, which means I could solve for y. Okay, that's what this is all about. Right here, let's jump back to the first one. I'll choose a different color. I begin with y equals x to the third plus 1/2. Because f of x really just means y, right? It's function notation. But to do an inverse, I switch the x and the y. So it now becomes x equals y to the third plus 1/2. I change the x and the y. But to find the inverse function, we need to solve for y again. So subtract 1/2 on both sides. And then to get rid of a third, we do the cube root. And there's really nothing more to do to that, except for the very last step. We started in function notation. It should end in function notation. This kind of looks like, well, what'd you do to that original y? I didn't do anything. I found, like, to the original y, right? I found its inverse. So it's important, though it's subtle, it is important that you do this last step. The inverse is a cube root of x minus 1/2. All right, one more thing I wanted to say about this one. When you're dealing with inverses, sometimes you can almost predict what it would be. Like in an inverse, you could think of like opposite, right? If I said multiply, you would divide. If I said add, you would subtract. So reading this one, it says I'm going to begin with x to the third power and add 1/2. So I want to go opposite. I want to go completely opposite. If I read this left to right, I'm cubing it and then I'm adding. So instead of adding 1/2, I'm going to start with x and I'm going to subtract 1/2, right? I'm going backwards. And instead of cubing it, I'm taking the cube root, right? That's opposite. That's the inverse. And that's why this answer, it makes sense. Some of them, they get too hard to do in our head, but some of them you can. If you literally think, do everything you did in reverse, do the opposite, that's the inverse. Second one was not 1-to-1. We can't do anything. We don't have an inverse. The last one, though. 1 minus x over x. To do that opposite in my head, I don't even know where to begin, right? Like, could you? Maybe. I don't know how. So instead, what we're going to do is the normal algebraic way. Y equals 1 minus x over x. First step, right? Just make it a y. Second step, anywhere there's an x, you put a y, and anywhere there's a y, you put an x. So we now have x equals 1 minus y over y. Now our goal is to solve for y. We want this as a function. So I'm just going to multiply both sides by y. So we have xy equals 1 minus y. Now we have two y's, so the trick, remember to solve for that, is group. So like group them all on one side. So I'm going to add y to the other side. So we have xy plus y equals 1. And to solve for y, we factor out a y. And now to isolate it, right, just divide that 1 plus x. And remember your end result, always change that y to f inverse. Function notation. So the inverse of this is 1 over 1 plus x.